Can an artificial intelligence learn to think better just by grading its own homework? This paper explores whether large language models can bootstrap their reasoning skills by learning specifically from their own successes. Modern models like GPT-4 are often trained on web data that actually contains text generated by previous models. Understanding this recursive loop is vital because, without careful management, it can lead to model collapse, where the system creates increasingly nonsensical outputs. To address this, the researchers diverge from the typical reinforcement learning path, which often requires complex human-designed reward functions. Instead, they investigate a simpler method driven by binary validation, essentially asking, did the plan work or fail? Let's examine the specific mechanism they use to turn simple validation into a powerful learning signal. The process is a repeating cycle starting with deployment, where the current model attempts various tasks. An automated tool validates the results, discarding failures and keeping only the correct plans to fine-tune the next version of the model. This loop effectively creates a self-made curriculum. By mastering easy tasks first, the model gains the logical building blocks needed to tackle harder problems in subsequent generations, effectively bootstrapping its own intelligence. The team implemented this using the Qwen 3.4b model and LoRa for efficient fine-tuning. When multiple solutions were found, the system was programmed to prefer the most efficient ones, selecting specifically for shorter plans and fewer reasoning tokens. Mathematically, this approach is significant because the authors prove it is equivalent to a special case of the reinforce algorithm. The binary validation acts as an implicit reward function, achieving policy gradient learning without a separate reward model. Now, let's look at the concrete results this self-improving loop achieved across different planning domains. Across domains like blocks world and rovers, the improvements were dramatic. Within just 5 generations, models often more than doubled their success rates, with the rovers domain seeing a massive 401% boost in performance. However, the method isn't magic. Performance gains began to plateau after about 5 iterations. Furthermore, the paper warns that these implicit rewards created by iterative deployment might eventually clash with safety training in ways that are hard to detect. To learn more, head to emergentmind.com.